Skylab drifted above Earth exactly as it was supposed to. The launch was over. The climb through the atmosphere was complete. America's first space station had reached orbit. From a distance, everything about the scene suggested success. A new habitat circled the planet against the blackness of space, carrying years of planning and expectation with it. Orbit was supposed to be the finish line. Instead, it was the beginning of the problem. The first signs arrived through telemetry, then through images. Something was missing. Part of the station's protective shield had torn away during ascent. One solar array had been ripped completely off. Another remained attached but appeared jammed in place. The station had survived launch. The station had not arrived intact. Suddenly, the meaning of that image changed. Skylab was no longer simply America's first space station. It was a damaged structure drifting hundreds of miles above Earth, exposed to an environment that never stopped applying pressure. The mission had reached space. The station had not yet become a station. Sunlight poured directly onto the exposed workshop section. The missing shield had done more than remove a piece of hardware. It had changed the station's relationship with its environment. Inside, temperatures began climbing. Outside, the remaining solar array refused to unfold. One launch event had created two separate problems. The station was becoming too hot while simultaneously producing too little electrical power. At first, the damage seemed understandable. Engineers could identify what had happened. Repair concepts appeared. The planned crew mission was delayed, not canceled. That felt reassuring. A damaged station could probably be repaired. But the station continued orbiting in sunlight. Each pass around Earth brought more heating. Power remained limited. Systems that depended on electricity faced restrictions. Equipment that had been designed for a functioning station now had to operate inside a habitat struggling to survive. The visible damage was only the beginning. The real threat was what the damage was doing to everything else. The exposed workshop became the defining image of the crisis. Its outer surface faced the sun without the protection it had been designed to carry. Temperatures rose. Conditions inside moved farther away from what astronauts would need. The station was still there. The station was still operating. Yet a new question was becoming impossible to ignore. Could anyone safely live inside it? NASA's response revealed how serious the situation had become. The crew would not launch immediately. Instead, engineers redesigned procedures, modified equipment, and searched for ways to rescue a place that had never been intended to be repaired in this manner. The challenge was unusual. No astronauts were trapped. No crew required evacuation. The object needing rescue was the habitat itself. Every day preserved possibility or removed it, and recovery margin was slowly disappearing. Plans emerged around an improvised solution. A parasol-like sunshade could be deployed to create artificial protection where the original shield had been lost. The idea was simple enough to describe. The risk was whether it would actually work in orbit. The astronauts prepared for a mission unlike the one originally planned. They would not merely occupy Skylab. They would try to save it. When the crew finally reached the station, the damaged structure still floated overhead, carrying all the uncertainty that had accumulated since launch. The first major repair effort focused on the overheating problem. The parasol deployment became one of the most important moments in the station's survival. A folded sunshade emerged from the damaged workshop and spread into position. For the first time since launch, Skylab began regaining protection from direct sunlight. The image was dramatic. The exposed station now carried a visible sign that recovery might still be possible. And gradually, temperatures improved. Conditions inside became more manageable. The station was no longer spiraling toward an overheated future. For a moment, the story seemed close to resolution. The station had been cooled. The astronauts had arrived. The rescue appeared to be working. But the most comfortable explanation in the story was about to collapse. If cooling the station solved the crisis, then Skylab should now function as intended. It didn't. The jammed solar array remained a problem. Electrical power remained limited. The habitat could survive more comfortably than before, yet survival and operation were not the same thing. The station was cooler. The station was still not fully a station. The contradiction at the heart of the mission became impossible to ignore. Repairing one failure had not repaired the habitat. Multiple systems now depended on one another for success. Power affected operations. Operations affected usefulness. Usefulness determined whether America's first space station could fulfill the purpose for which it had been launched. Another recovery path had disappeared. Only a few remained. Attention turned toward the stubborn solar array still locked against the side of the station. Astronauts worked outside the damaged structure, confronting hardware that had never been expected to require this kind of intervention. The station itself became a repair site. Not a destination. Not yet. A repair target. Eventually, persistence produced movement. The jammed solar array was freed. As it unfolded, the station recovered desperately needed generating capability. The change was visible. The damaged habitat that had entered orbit overheated and underpowered was slowly becoming something else. Systems regained capability. Operations expanded. The station could finally support the activities it had been designed to host. The transformation had not occurred through one dramatic fix. It happened through a sequence of survival victories. First, the station had to remain recoverable.
Skylab Houston, we show you
Then it had to be cooled.
Maneuver 3.
Then it had to regain power. Only after overcoming each separate constraint could it become habitable. The image from the beginning returns here. A space station drifting in orbit. At launch, that image appeared to represent success. Then it became evidence of failure. An exposed structure, missing protection, damaged hardware, a habitat that might never fulfill its purpose. By the end, the same image means something different. The scars remain part of the story, but now they represent proof. Proof that damaged infrastructure in space does not automatically have to be abandoned. Proof that a place can survive long enough for solutions to work. And proof that Skylab's greatest contribution began the moment its launch stopped being a success story and became a rescue story. The station reached orbit as America's first space station. It became a real station only after it was saved.